In this section, we will start with hypothesis testing about a proportion. Listed here are the requirements along with the formula for the test statistic. The two methods we will use for hypothesis testing are the traditional method, which uses the critical values and test statistic, and the p-value method, which uses the p-value and the level of significance. For the traditional method, if the test statistic falls within the critical region, we reject HO. If the test statistic does not fall in the critical region, fail to reject HO. For the p-value method, if p-value is less than alpha, we reject HO. If p-value is greater than alpha, fail to reject HO. For this first example, we will use the traditional method. First, we read the problem carefully and make sure we understand what the claim is. In this example, the claim is based on the null hypothesis, so write that. Since HO is how we base the claim, the alternate hypothesis, HA, will be P not equal to 0.60. And this means that we will be doing a two-tailed test. Note that the level of significance is 0.10. Step 2, we need to find the test statistic. So recall that formula. Now we just need to make sure we have all the information to plug into the formula. N equals 500. P hat will be 350 out of 500, so 0.70. Now we just plug in the information into the formula and evaluate on our calculator. We get the value of our test statistic being 4.56. Now we move on to step 3, which is finding the critical values in this case, since we have a two-tailed test. Let's draw a diagram real quick. Since it's a two-tailed test and our level of significance is 0.0 or 0.1, we split that up so the critical values will have 0.05 in their critical regions. And we go to our handy dandy calculator to evaluate this. Recall the inverse norm function. We end up with critical values plus or minus 1.645. And from step 2, we can see that our test statistic falls into the critical region. So since the test statistic is in the critical region, we can reject the null hypothesis. Now we can state our conclusion. There is sufficient evidence to warrant the rejection of the claim that the true percentage of Democrats in CCC is 60%. Another example using the traditional method. First, we need to identify the claim, which is in the form of the null hypothesis. Which means the alternate hypothesis, HA, is P greater than 0.75. And that means we will be doing a right-tail test. Step 2, we need to find the test statistic. Writing the formula down for the test statistic. We need p hat, which is 68 out of 100, or 0.68. N equals 100 trees, and we have P equals 0.75, and Q being equal to 0.25. Plugging the information into the formula and then letting our calculator evaluate. And we get the test statistic being negative 1.62. Now we find the critical value. Drawing a diagram real quick. Since we are using a significance of 0.04, we input that into our calculator using the inverse norm function. We see that the test statistic is not in the critical region, so we fail to reject the null hypothesis. So we can say that there is not sufficient evidence to warrant rejection of the claim that the true percentage of pine trees is over 75%. Now we look at type 1 and type 2 error real quick. Type 1 error is the mistake of rejecting the null hypothesis when it is actually true. Type 2 error is the mistake of failing to reject the null hypothesis when it is actually false. Below are a couple of examples of the type 1 and type 2 errors. Of course, it makes sense to try not to make these errors, so to reduce that, make sure sample size is large enough. Now we will take a look at hypothesis tests about a mean where we know population standard deviation. Also on this page, we see the requirements as well as formula for the test statistic. Now for an example. We will use the p-value method for this one. Let's start by labeling some key information such as n, sample mean, and population standard deviation. And we are using a 0.05 level of significance. The claim is about the alternate hypothesis, HA. Now we find the test statistic. So let's write the formula for the test statistic when we have population standard deviation. Using our calculator to evaluate. and we get 2.33 as our test statistic. Now we find the p-value. Since this is a two-tailed test, we multiply the p-value by 2. Using the normal CDF function on our calculator, we get 0.0099 as our p-value. And then this is less than our level of significance 0.05, so we reject the null hypothesis HO. So we can say the sample data support the claim that mean sitting heights at that particular school is different from 91.4 centimeters. Next example. Again, we will use the p-value method for this one. Labeling some key information. Our claim is about the alternate hypothesis HA. And this is a left-tailed test. Now we find the test statistic. Writing the formula for a test statistic when we know population standard deviation. And now we use our calculator to evaluate. So our test statistic is negative 2.23. So now we find the p-value using the normal CDF function. Whoops, entered the wrong test statistic. Entering it incorrectly, we get 0.0129 as the p-value, which is greater than our significance of 0.01. So we fail to reject the null hypothesis. So there is not sufficient evidence to support claim that mean is less than 5.4.